Hello lovelies, you're welcome to my channel once again. So today we have a very interesting math problem to resolve. We have 9 to the power of x minus 6 to the power of x to be equal to 4 to the power of x. So first to begin, let's divide both sides by 4 to the power of x. So we have 9 to the power of x all over 4 to the power of x minus 6 to the power of x all over 4 to the power of x to be equal to 4 to the power of x over 4 to the power of x. So when we divide this, we have 9 to the power of x over 4 to the power of x minus 6 to the power of x over 4 to the power of x to be equal to 1. From law of indices, when we have a to the power of n over b to the power of n, this is the same as a over b all to the power of n. So 9 to the power of x over 4 to the power of x becomes 9 over 4 all to the power of x minus this becomes 6 over 4 all to the power of x to be equal to 1. So the index form of 9 is 3 to the power of 2. While writing 4 in index form, we have 2 to the power of 2 further raised to the power of x minus, we can divide this by 2. 6 into 2 we have 3 and 4 into 2 we have 2 all to the power of x, which is equal to 1. So we have here, let's recall that when we have a to the power of m further raised to the power of n, this is the same as a to the power of n further raised to the power of m, and is also equal to a to the power of m times m. So imputing this here, we'll have 3 over 2 further raised to the power of 2 further raised to the power of x minus 3 over 2 all to the power of x, which is equal to 1. So interchanging the powers, we have 3 over 2 all to the power of x further raised to the power of 2 minus 3 over 2 all to the power of x, which is equal to 1. So we have 3 over 2 to the power of x. We have 3 over 2 to the power of x. So let p be equal to 3 over 2 all to the power of x. So this 3 over 2 to the power of x further raised to the power of 2. So we now have p squared. So we have 3 over 2 all to the power of x, which is p. We have p squared minus here is p, which is equal to 1. So moving this over, we have p squared minus p minus 1 equal to 0. So this is a quadratic equation. We can use the quadratic formula to resolve this, where a is equal to 1, b is equal to minus 1, and c is equal to minus 1. So let's recall that a is equal to 1, b is equal to minus 1, and c is equal to minus 1. So imputing this value, we have b to be equal to minus, our b is minus 1, plus or minus the square root of minus 1 all squared, minus 4 times 1 times minus 1, all over 2 times 1. So p is equal to, so this negative cancels out. We have 1 plus or minus, we have 1 minus, so 4 times 1 times 1, we have positive 4 all over 2. So our p is equal to 1 plus or minus root 5 over 2. This simply means that p is equal to 1 minus root 5 over 2, or 1 plus root 5 over 2. So we'll name this case 1, and this will be case 2. So for case 1, p is equal to 1 minus root 5 over 2. And let's recall that our p is equal to 3 over 2 all to the power of x. So imputing the value of p here, we have 3 over 2 all to the power of x is equal to 1 minus root 5 over 2. Looking at this, we have a positive value here and we have a negative value here. So case 1 is rejected. So we'll move to case 2. So for case 2, we have p to be equal to 1 plus root 5 over 2. And our p is 3 over 2 all to the power of x, which is equal to 1 plus root 5. So from here, let's take the log of both sides. So we have log of 3 over 2 to the power of x is equal to log of 1 plus root 5 over 2. But when we have log to base b of a to the power of x, this is equal to s times log to base b of a. So we have log to base 3 over 2 of 3 over 2 all to the power of x equal to log to base 3 over 2 of 1 plus root 5 over 2. So this becomes x times log to base 3 over 2 of 3 over 2 equal to log to base 3 over 2 of 1 plus root 5 over 2. But when we have log to base c of c, this is equal to 1. So log to base 3 over 2 of 3 over 2 becomes x times 1 equal to log to base 3 over 2 of 1 plus root 5 over 2. From here, log to base b of a is equal to log to base m of a all over log to base m of b. So we have x times 1, which is x, is equal to, we have log of 1 plus root 5 over 2 all over log of 3 over 2. So from law of indices, law of logarithm, we have log a over b to be equal to log a minus log b. So our x is equal to, for the numerator, we have log of 1 plus root 5 minus log of 2 all over, for the denominator, we have log of 3 minus log of 2. So our x is equal to log of 1 plus root 5 is 3.236 minus log of 2 all over log of 3 minus log of 2. So our x is equal to log of 3.236 is 0.51 minus log of 2 is 0.301 all over log of 3 is 0.4771 minus 0.301. So our x is equal to 0.209 all over 0.1761, which is equal to 1.1868. So our x is equal to 1.1868. So let's verify. We have x, we got x as 1.1868, and the question is 9 to the power of x minus 6 to the power of x. equal to 4 to the power of x. So we'll be imputing the value of x to have 9 to the power of 1.1868 minus 6 to the power of 1.1868 equal to 4 to the power of 1.1868. So 9 to the power of this will give us 13.5673 minus 6 to the power of this, we have 8.3851, or equal to 4 to the power of this, we have 5.1823. So subtracting this from here, we have 5.1822 equal to 5.1823. So this is approximately the same. So it means that the left hand side equals the right hand side. Thank you for watching to the end of this video. Subscribe and hit the notification bell so you don't miss out on any of our solutions.